Hello everyone, and welcome to another new short tutorial by CS. My name is Abderrahim and I'm working as an application engineer here at CS. And CS is the exclusive partner of MathWorks in the region of Middle East. Today's video will be about Signal Analyzer app, and I will be showing you how you can use this app to complete the workflow for a Doppler signal analysis and preprocessing. So let's get started. The first thing in my workflow is to load my Doppler signal to MATLAB Workspace. And for this reason, I will use load function, and the argument is my noisy Doppler signal. So now I have my noisy Doppler signal here in Workspace. Then now we can go ahead and start the Signal Analyzer app. And to do that, I will need to go to Apps tab, then Signal Processing and Communication family, and then I need to find Signal Analyzer, which is just here. Okay, so now I have just started my Signal Analyzer app, and this is actually the default window that you're gonna see when you start Signal Analyzer app. So by default, we have two displays, and you have some tabs here, Analyzer tabs, you have display tabs, and they have time tabs, okay? And in each one of these tabs, you have some options and tools. As you can see here in Analyzer, we have preprocessing library, and we can use this generate function to generate code. And in display tab, we have many other options, and especially for the analysis in time domain, in time frequency domain, and in frequency domain. And they have this data cursors here. And mainly have this workspace browser. So in this workspace, which is actually like a local workspace, have my noisy Doppler signal. And to start my analysis, I need first to move this signal to this filter signals library. And to do that, I will need to drag and drop like this. And as you can see now, my signal, it is now in filter signals library. And you can now go ahead and select it. So now you can see it's visualized in time domain, okay? But first I need to create a version of my noisy Doppler signal. And to do that, click right, then duplicate. And it's now, it has now a default name. You can rename it by double click on it, then give it a name, for example, smoothed noisy Doppler signal. So we have now two signals. The first one is the original, and this is a, a second version that I have just created. Actually, it's the same signal, and I will use this one, which is the original one, for the comparison. And my pre-processing will be performed on this new version of my signal, okay? So now I will display both of them in time domain. Okay, as you can see, now I have my two signals, and now I can start my analysis. Actually, we are analyzing in time domain, but we can again perform this analysis in frequency domain. And we have here this spectrum. So I can now view the frequency spectrum of my noisy Doppler signal by selecting, for example, spectrum. As you can see now, here I have the power spectrum of my noisy Doppler signal. And as you can see, also there is this new tab here called spectrum. So now you have some options here that you may need to adjust or modify. let's say I'm not happy with this power spectrum and I'm looking for more accuracy so it can uh, work on this frequency resolution, for example, or it can again play with this leakage. And as you can see, my power spectrum is updating. And it can again do the same with this new version of my Doppler signal. Select this display and then go to display here and select spectrum. Okay, so now we have um, my two signals with their power spectrum. I can just now go ahead and deselect this and deselect this. And next is time frequency analysis. And to do that, you have this option here, which is time frequency. And we have again two options. Here we have spectrogram and we have scaleogram. Now, for this analysis and preprocessing, we're going to use scaleogram and we're going to use the noise function from which is based on wavelet transform. Okay, so I will go ahead and uh, close or view the scaleogram of the original signal, and then we'll do the same with this duplicate here. Okay, so as you can see, they are the same with the same scaleogram and everything. Okay, so next is to for example, I want more resolution in my scaleogram on this samples axis or on this frequency axis. So we have this new tab here, scaleogram. I can change many things. For example, I have frequency resolution. I can change it from here and or from here, as you can see. And actually I can do the same with this one. Okay, so now we have my scaleogram updated. Okay, so the next step is to remove this noise. As you can see, my signal has a lot of noise, and the pre-processing that it will perform will be on this duplicate version that you have created. Okay, so select this display here and go to Analyzer, then go to Preprocessing and select this noise function. But before that, as you can see here, we have many other preprocessing options. For this signal smoothing, I will use the noise, which is based on wavelet transform. Okay. Then I have this default configuration for my denoise function. I have the wavelets family with the identifier and everything, and they have the method, the level, the rule, and they have again the noise estimate method. So I will just keep this default configuration and start the pre-processing by clicking on this the noise button. And I will just accept overwriting my original signal. Then as you can see here, now we have my signal, and as you can see, it's smoothed. There is now less noise. You can use options that you have here, click right, then for example, use this zoom in to zoom in this place. As you can see, it still have some noise. For example, let's say I'm not happy with this pre-processing. I can go back to my the noise function and change the number, for example, 6, and change the method or the rule to mean, for example, and start the pre-processing again. Okay. So now, as you can see, have less noise. Let's go back to the view, fit to view from here. And now we have my signal. And now I'm happy with this signal. And I want to export first this smoothed signal to MATLAB Workspace. To do that, go here to filter signals and select the signal that you want to export, then click export. Then you have again two options here. You have export to MATLAB Workspace or export to MAT file. Okay. I will select now this export to MATLAB Workspace, and I will click export. Now go to MATLAB Workspace. Now, as you can see here, you have this new signal, which is actually smoothed. You can select it and close it from here. And as you can see, it is smoothed and everything. Let's go back now to Signal Analyzer and do something that you might be interested in, which is generate the code for this preprocessing. I will now close the preprocessing window, and I will generate the function for this preprocessing. To do that, I have this generate function here, this option, and I will just click on this, and as you can see here, I have now this the noise function, or this preprocessing function, which has two functions of the noise based wavelet transform. Okay. So now I have my function for the preprocessing that I performed. I have this smoothed signal. I can now go back to Signal Analyzer and save my session for further processing or preprocessing or analysis. Okay, and to do that, go ahead and click on the Save As. Okay, now, for example, I will go to desktop and give this session a name, for example, Doppler signal analysis and pre-processing. Okay, so now I showed you the workflow for a Doppler signal analysis and pre-processing, and showed you in the end how you can export to MATLAB Workspace and how you can generate a function for your pre-processing. And so now times to try this at your end and leave a comment in comment section. See you next video. Bye.